TechDaily.ai, your source for technical information. This podcast is sponsored by Stonefly, your trusted solution provider and advisor in enterprise storage, backup, disaster recovery, hyper-converged in VMware, Hyper-V, Proxmox cluster, AI servers, SA365, a turnkey security appliance, and public and private cloud. Check out stonefly.com or email your project requirements to sales@stonefly.com. Welcome to the Deep Dive. Today we're tackling something that sounds really simple on the surface, direct attached storage, DAS.
Right.
But, it's actually gone through this quiet revolution. Maybe you picture like an old server stuffed with disks, but what DAS means today is, it's pretty different.
It really is.
So our mission here is to get past that basic idea. We want to trace how DAS evolved, figure out why it's suddenly so relevant again, and show how it's actually changing things for applications, even for cloud setups. There are some surprises in store.
Yeah, that's a good way to put it. Storage is, fundamental. It's the bedrock, but it's always changing. And while everyone was talking about SANs and NAS for years, DAS was kind of doing its own thing in the background. And its comeback, especially these newer forms, it's shaking things up. System design, the market, it's having a real impact that people might miss at first glance.
Okay, let's start simple then. The name, direct attached storage. Sounds obvious, yeah. Storage hooks right up to a server.
It does sound obvious, but the direct part is key. It means the connection path, it completely bypasses any shared switched network.
So no fiber channel switches, no Ethernet fabric acting as the storage network.
Exactly, that's the opposite. With DAS, the server has its own dedicated link. It gets basically exclusive access to those disks or storage resources. No sharing bandwidth, no network negotiation for that access.
Gotcha. So it's not like grabbing a file over the office Wi-Fi, which is more like NAS, or going through a complex SAN highway. It's more like plugging an external drive straight into your laptop, a direct line.
That's a great analogy, a one-to-one or maybe one-to-a-few relationship. And yeah, historically, that did mean disks literally inside the server box.
Right.
But in the broader storage world, it pretty quickly came to mean external boxes, too. The classic term is JBOD.
Just a bunch of disks.
Just a bunch of disks, exactly. Basically shelves full of drives, connected usually by a high-speed cable like SAS, directly into a host bus adapter and HBA card in the server.
Okay, the classic JBOD shelf.
Yeah.
And the reasons for using those back then were, pretty straightforward, weren't they?
Yeah, mostly two things. One, you just ran out of space inside the server, simple capacity expansion.
Need more gigabytes, add a shelf.
Pretty much. But the other big reason was performance, specifically IOPS, input-output operations per second.
Right.
Before shared arrays got really smart with caching and tiering, a reliable way to boost how many reads and writes a server could handle per second was just add more physical disks, more spindles spinning.
So the JPOD gave you more spindles directly connected to that one server.
Exactly. Boosting its raw IOPS potential, especially for applications that hammered the disks.
Okay, so that's the old school picture. Internal disks, or these simple JBOD shelves, capacity, brute force, IOPS, seems basic. But you said revolution. Where did things start to change?
Right, here's the big twist. And it's honestly a massive shift. The intelligence, the smarts that used to only be in those expensive, dedicated storage array boxes. It started moving.
Moving where?
Up the stack, into the operating systems, and this is critical, into the applications themselves. Vendors started building sophisticated storage logic right into their software.
Hold on. The intelligence moved from the specialized hardware to the software. For direct attached storage, that feels backwards.
It does, and that's the key insight. When the application or the OS gets smart about managing data, how it's placed, protected, accessed across disks, it changes what you need from the hardware underneath.
I see. So you might not need that super expensive SAN array anymore if the application itself can handle, say, data redundancy.
Precisely. If the app can manage data protection or performance optimization, the underlying storage can be simpler, maybe cheaper, like DAS.
And the prime example often cited is Microsoft Exchange, right? Version 2010 specifically. Before that, if you wanted large-scale Exchange, you pretty much had to use a SAN.
Oh, absolutely. Older Exchange versions were notoriously hard on storage. Very random I/O patterns. SANs, with their big caches and dedicated controllers, were built for that. Plus, features like replicating mailboxes, that was often a SAN-level task.
So what changed with Exchange 2010?
Two major things. First, Microsoft really optimized the I/O profile of Exchange itself, made it less demanding, more sequential. Second, and this was the game changer, they introduced database availability groups, DAGs.
DAGs. Okay, what did they let you do?
DAGs allowed multiple Exchange servers, each potentially using its own local storage, often just DAS with cheaper, high-capacity drives, to replicate the mailbox databases between themselves, just using the regular network.
Whoa, so if one server failed,
Another server in the DAG already had an up-to-date copy of the data and could just take over the services automatically.
so the application was handling the data replication and the failover using standard networking across servers with their own cheap DAS disks, instead of relying on the expensive SAN hardware.
Exactly that. And the really significant thing was Microsoft was actively promoting this. They designed Exchange 2010 so that using DAS was a perfectly valid, even recommended way to build large, resilient, low-cost mailbox systems.
That's huge. It wasn't just for small setups anymore.
Not at all. It meant huge organizations could deploy tons of mailboxes using much less expensive storage hardware without giving up the high availability and performance they expected. It totally repositioned DAS for critical enterprise applications.
Wow, moving that intelligence, that availability logic into the app layer.
Yeah.
Yeah, that changes the storage underneath completely. But it didn't stop there, right? Today's DAS isn't always just one server talking to one box of disks either.
No, the evolution kept going. We started seeing concepts like shared DAS, or sometimes called direct area networks DANs.
Shared DANs. How does that work if it's direct?
It's about multiple servers connecting to a shared set of drives or array controllers, but, and this is the key part still, without needing that separate switched SAN fabric in the middle.
So multiple servers see the same storage pool, but there's no fiber channel switch or dedicated Ethernet storage switch involved.
Right. The implementation varies, but think maybe modular storage arrays designed for, say, mid-market clusters. They might have ports, SAS ports, typically allowing maybe 4 servers to plug directly into the array's controllers.
Okay, so those 4 servers could share the storage for clustering, maybe for virtual machines.
Exactly. And they get shared access, they get failover if a controller fails, but without the cost and complexity of building a whole SAN. No SAN switches, no expensive fiber channel HBAs needed in every single server, less management headache. It's a cost-effective middle ground.
That makes sense for the mid-market. But then you mentioned examples at the really high end too, like that HP blade system thing. That sounded wild.
Yeah, that's where direct attached gets stretched in surprising ways. Using technologies like HP's Virtual Connect Flex Fabric inside their blade chassis and what they call flat SAN technology, you can connect a frankly astonishing number of servers.
How many are we talking?
The example mentioned was over 700 servers in one system.
700 servers.
Yeah.
Directly connected to a big storage array like a 3PAR without SAN switches. And without fiber channel cards in every blade. How is that even possible?
Sounds like it breaks the rules, right? But the trick is in converged networking within the blade system itself. That flex fabric stuff, it lets the connections handle both regular network traffic and storage traffic over the same physical links coming out of the chassis.
Okay.
And the flat SAN part means they aggregate all those storage connections inside the blade environment and present them directly to the storage array, bypassing the need for external SAN switches. It collapses layers of hardware.
That's barely recognizable as direct attached in the traditional sense. The scale is just massive.
It completely redefines the term at the enterprise level. It shows vendors innovating on the connectivity part of DAS, making it simpler and maybe cheaper to connect lots of servers compared to traditional SANs.
Okay, so DAS evolves for enterprise apps, scales up with shared DAS and these massive direct connect architectures. What about the cloud? You mentioned cloud providers are using DAS concepts too, but differently.
Absolutely, especially the big independent public cloud players. Think companies like Dropbox, building huge scale services, not just reselling old IT models.
Right, they're building new stuff designed for the cloud.
Yeah.
And their storage is based on
deploying just enormous fleets of what are basically storage servers, commodity servers packed absolutely full of low-cost, high-capacity disks, often in simple JBOD-style enclosures.
like the JBODs we talked about, just thousands of them.
Kind of, yeah. But the critical difference, the real innovation, is the software. They build or use open source, incredibly sophisticated software layers to manage all that directly attached capacity spread across maybe thousands of servers.
So the intelligence isn't in the hardware boxes at all.
Not really. The software handles everything. Where data gets placed, how it's replicated for redundancy, how it's accessed. It pulls all those cheap disks together. It's software-defined storage running on standard servers connected to standard DAS drives.
And they do this because it's cheaper.
Fundamentally, yes. Their whole business model relies on hitting extremely competitive price points per gigabyte. By ditching expensive proprietary array controllers and SAN fabrics and using smart software on commodity hardware, they achieve the scale and cost efficiency they need. It's a totally different model, but built on DAS principles combined with software smarts.
Okay, let me recap this journey. DAS starts as disks inside a server, then external JBODs for capacity and just adding more spindles for IOPS. Then boom, Exchange 2010 makes it viable for critical apps because the application got smarter.
Yeah.
Then we get shared DAS and these crazy large-scale direct connection methods bypassing SANs. And finally, the cloud giants use massive farms of DAS hardware managed entirely by software for cost efficiency.
That's a pretty good summary of the evolution, yeah. It's come a long way from just being disks in a box.
So what does all this mean for the market, for the storage vendors?
Well, it creates some clear winners and losers, doesn't it? As application vendors put more storage intelligence into their software, it gives them more power. And it puts pressure on the traditional storage-only companies.
The ones whose value is primarily in that intelligent hardware array and the SAN switch is connecting everything.
Exactly. Their traditional value proposition is being challenged. Conversely, vendors who are strong in both servers, the compute part, and have good DAS offerings, they're often in a better position.
Because they can sell the whole integrated package that fits these newer architectures.
Precisely. They can provide the servers and the direct attached storage that works hand in glove with either application-level intelligence or these software-defined storage layers. The whole center of gravity for storage intelligence and therefore market value seems to be shifting.
Shifting away from the dedicated storage network and hardware.
And more towards the application itself, where the software layer is running on more standardized, directly connected hardware.
So DAS isn't fading away. It's actually enabling entirely new ways of building storage, from enterprise apps to hyperscale clouds.
It's being constantly redefined by software and by new ways of connecting things. It's enabling architectures that just weren't feasible or were way too expensive not that long ago.
Okay, here's a final thought for everyone listening then, based on all this. If applications keep absorbing storage functions and direct connections get easier and bigger, could the future of storage be dictated more by the software we choose rather than the specific storage hardware underneath? Something to chew on.
It's a powerful trend. Think about where else you see that pattern intelligence moving closer to the compute, leveraging direct links. It pops up in a lot of places in tech.
Definitely something to watch. Thanks for breaking down the surprisingly complex world of DAS today. TechDaily.ai, your source for technical information. This podcast is sponsored by Stonefly, your trusted solution provider and advisor in enterprise storage, backup, disaster recovery, hyper-converged in VMware, Hyper-V, Proxmox cluster AI servers, S-Day365, a turnkey security appliance, and public and private cloud. Check out stonefly.com or email your project requirements to sales@stonefly.com.